Good evening. In today's class, I am going to explain you some more problems based from the topic system of particles given in previous JEE main. In particular, today we are going to see problems based on moment of inertia. So, let us move on to the problems. Look here, center of mass of a solid hemisphere of radius 8 centimeters. Radius of the hemisphere is given as 8 centimeters. So, what is x centimeters from the center of the flat surface? So, hemisphere, let us represent the hemisphere like this. This is the flat surface center, and we have derived the expression for distance of center of mass of the hemisphere from the center of the flat surface, that is x is equal to 3r by 8. You just go through the synopsis part of center of mass. We had that derivation already. So, just if you from this derivation x is equal to 3, r is given as 8 centimeters, 3r by 8. So, x is equal to 3 centimeters. So, that is the answer. So, such kind of problems while reading the synopsis, you must know how to derive the expression, and then you better memorize certain formulae which are constant. For a hemisphere, always it is 3r by 8 from the center of the flat surface. Okay? Now, you can save lot of time if you remember such kind of formulae. Now, moment of inertia of a circular ring. It is a circular ring of mass m and diameter r, radius is r by 2. So, moment of inertia of a circular ring of mass m and diameter r about a tangent, about a tangential axis lying in the plane of the ring. Look here, suppose if this is the ring, moment of inertia of the ring about any diameter we know mr square by 2, where r is the radius of the ring. So, about a tangential axis in its plane, this is I. From parallel axis theorem, we have to consider an axis parallel to the given axis. So, axis parallel to the tangential axis is the diameter, right. So, tangential axis in the plane is equal to the diameter. Let us then we take this as moment of inertia of the object about an axis parallel to the given axis is in this case mr square by 2, and the perpendicular distance between the two axes is r. From parallel axis theorem, I is equal to Ig plus mr square. So, mr square by 2 plus mr square. See here, it is 3 by 2 mr square, where r is the radius. Now, look here, diameter is given as small r. So, radius diameter is 2r is equal to r. So, r is equal to r by 2. So, substituting that here, I is equal to 3 by 2 m r by 2 whole square. It is 3 by 8 mr square. So, you have to record the keywords here. Normally, if we look at r, we feel that it is the radius, but here it is the diameter of the ring given. It is about the tangential axis in the plane, that is 3 by 2 mr square, where r is small r by 2. So, the correct choice for that is 3 by 8 mr square. Move on to the next problem. Read the problem. A rod of linear mass density, mass per unit length is given as lambda, and length L is bent into the form of a ring of radius r. First of all, mass is equal to linear density into length. So, mass of the given rod is lambda into L. it is bent into the form of a ring of radius r. So, the total length is L. If it is bent into the form of a ring, the perimeter is 2 pi r. So, this is equal to 2 pi r. Moment of inertia of the ring about any of its diameters. We know about any of its diameters, moment of inertia is mr square by 2. But from this expression, r is equal to L by 2 pi. Substitute this value of r in this expression and this value of m. So, I is equal to m is lambda into L. R is L by 2 pi. R square is L square by 4 pi square. So, m r square by 2. So, this is lambda L cube by 8 pi square. That is the moment of inertia about any one of the diameters. Lambda L cube by 8 pi square. Go to the next problem. A circular disc of radius r and mass m kg. Radius r meters, mass is given as m kg, is rotating about an axis perpendicular to the disc. An external torque is applied on the disc such that theta t, that is the angular position, varies with time as per that equation. So, the variation of displacement with respect to time, angular displacement with respect to time is given as 5t square minus 8t, where theta is the angular position at any instant of time t. What is the power delivered by the applied torque in 2 seconds? We know power delivered is equal to tau omega, where you see we move parallel, we do the problems just parallel as we have done the problems in translatory motion. In case of translatory motion, power delivered by a force which maintains the velocity of the object uniform as equal to P is equal to Fv, where F is the force applied, V is the uniform velocity maintained by the applied force to the object. Now, here on applying the analogy for force in rotatory motion is torque. Analogy for velocity is angular velocity. So, power here becomes torque into omega. First, see, torque formula is I alpha. This is a circular disc. So, I is mr square by 2. For a circular disc, about an axis perpendicular to the disc is mr square by 2 into alpha. That is the torque. And angular velocity is d theta by dt. So, angular velocity, we get angular velocity by differentiating angular displacement with respect to time. So, just differentiate this with respect to time. 5 derivative of t square is 2t minus 8. So, angular velocity is 10t minus 8. Angular velocity is, so I am rewriting it here. So, angular velocity is equal to 10t minus 8. So, here angular velocity at t is equal to 2 seconds. So, omega is equal to 10, t is 2 minus 8. So, here it is 20 minus 8, omega is equal to 12 radian per second. Keep it aside. So, here we know m, we know r because they are given as mr. Now, we need to find out alpha. What is alpha? Angular acceleration. How do you get angular acceleration? By differentiating angular velocity with respect to time, you get angular acceleration. So, here it is just derivative of t is 1, so it is 10. angular acceleration is 10 radian per second square. So if you substitute all the values in the expression for the power, so power is equal to tau. Tau is I is mr square by 2, and alpha is 10 I alpha into omega is 12. So this is 60 mr square. This is the correct option for that problem. So power delivered is equal to 60 mr square. Okay, so that is the answer for that. Move on to the next problem. A system consists of two identical spheres, each of mass 1.5 kg, radius 50 centimeters, at the end of a light rod. So here let this be a light rod and two spheres are arranged at the ends of the rod. Okay, and mass of each sphere is given as 1.5 kg and radius of each sphere is given as 50 centimeters. If you convert that into meters, 0.5 meters. Distance between the centers of the two spheres is 5 meters. Right? What is the moment of inertia of the system about an axis perpendicular to the rod passing through the midpoint, like this? See here, as that is a massless rod, the rod has no moment of inertia. We have to just find out the moment of inertia of those two spheres about this axis passing through the center and perpendicular to the length of the rod. So here consists of two identical spheres. They are, if they do not mention the spheres as hollow, we take them as solid spheres. Okay, sometimes they mention them as solid, sometimes if they don't mention, we take them as solid spheres. So here moment of inertia of a solid sphere is 2 by 5 mr square. But if you want to find the moment of inertia of any object about an axis not passing through the center, we have to apply parallel axis theorem. That is, I is equal to, this is moment of inertia of this sphere about this axis is I. You have to apply parallel axis theorem. So moment of inertia of the solid sphere about any axis passing through the center of mass is 2 by 5 mr square. We take that as Ig in this problem, and this is the distance between the two parallel axes. So I is equal to Ig plus mr square. Here in this case, as the two spheres are identical and the axis is located at the center, moment of inertia of this pair about this axis also becomes the same. So the total moment of inertia is 2 into Ig plus mr square. So substitute the values. It is 2 into Ig is 2 by 5, mass is given as 1.5 kg, mass of each sphere is 1.5 kg, radius is given as 0.5 meters, 2 by 5 mr square plus m into square of the perpendicular distance between the two axes, that is 5 by 2, that is 2.5 into 2.5. You need to simplify that. So here this is 2 into, this gets cancelled 0.3 times. So 2.5 is 1 by 2, right? So this and this gets cancelled. 0.3 into 0.5 is 0.15 plus 1.5 into 2.5 into 2.5 is 6.25. You need to simplify that. So here just take 0.15 as a common factor. So 1, here it is 10, 0.15 into 10. 10 into 6.25 is 62.5. So this becomes 2 into 0.15 is 0.3 into 63.5. So 63.5 into 3. So it is, look here. So if you forget about the decimal points, 3 5s are 15, 3 3s are 9, 1, 10, 3 6 are 18, 19. So it is 19.05 kg meter square. That is the answer, right? So move on to the next problem. Look here. Consider a uniform wire of mass m, length L. It is bent into the form of a semicircle. Its moment of inertia about a line perpendicular to the plane of the wire passing through the center. The length of the wire is L here. That wire is bent into the form of a semicircle. About this, we want to find out the moment of inertia about a line perpendicular to the plane of the wire passing through the center, like this. Okay, so then it is just equal to mr square, where r is the radius. So here moment of inertia is mr square, and we need to find out the radius of the semicircular arc. The total wire is bent into the form of a semicircle. So semicircle perimeter, or this is pi r, from which r is equal to L by pi. So just substitute that over there, ml square by pi square. That is the correct option for that problem. Okay. So here you are supposed to find moment of inertia about a line passing perpendicular to the plane of the semicircle and passing through the center. Okay. Move on to the next problem. Moment of inertia of 4 bodies having the same mass and radius. Mass and radius of all bodies are same. Okay. It is reported as I1 moment of inertia of a circular ring about its diameter. Moment of inertia of a circular ring about its diameter is mr square by 2. Next, I2. Moment of inertia of a circular disc about any axis perpendicular to the disc. That is mr square by 2. I3. Moment of inertia of a solid cylinder about its axis. So solid cylinder about its axis, natural axis, that is I3 is also equal to mr square by 2. Now I4. Moment of inertia of a solid sphere about its diameter. So solid sphere about its diameter is 2 by 5 mr square. Now see, you need to mr square by 2, mr square by 2, that is I1 is equal to I2 is equal to I3, and moment of inertia is 1 by 2 is 0.5 mr square. And now I4, 2 by 5 is 0.4 mr square. So definitely this I4 is less than all this. So I1 is equal to I2 is equal to I3 greater than I4. That is the correct answer. You have to be very careful. I1 is I2 is I3, that is simple. But coming to I4, it is 2 by 5 mr square, 0.5 mr square. So you could do that. Okay. Move on to the next problem. Moment of inertia of a rod of mass m, length L, about an axis passing through its center, normal to its length. See, if this is a rod about this axis, moment of inertia it is given as alpha here. In this particular problem, it is given as alpha. So alpha is equal to ml square by 12. Moment of inertia of a thin rod about an axis passing through the center perpendicular to its length is ml square by 12. Now, it is cut into two equal pieces and these parts are joined symmetrically to form a cross shape. So, the two pieces are cut in, the rod is cut into two equal pieces and two pieces are joined in the form of a cross at right angles at the center. So, what is the moment of inertia of the system about an axis passing through its center and normal to the plane containing the cross? Look here, for this mass is m by 2, length is L by 2, ml square becomes m L by 2 whole square. About any axis through its center, ml square by 12 formula. So, moment of each rod is this much. So, new moment of inertia of this system about an axis passing through the center and perpendicular to the plane is 2 times this. So, m L square, 2 4s are 8, 8 into 12, right. So, 4 gets cancelled, this is ml square by 4 into 12. But ml square by 12 is given as alpha. So, I dash is equal to alpha by 4. So, I dash is equal to alpha by 4. Okay. Move on to the next problem. Look here. A uniform circular disc of radius r, mass m is rotating about an axis. This is a circular disc of radius r, mass m, rotating about an axis perpendicular to its plane passing through the center. Let this be the center, right. A small circular part of radius r by 2 is removed from the original disc. Find the moment of inertia of the remaining part of the original disc about the axis given above. Look here, let this be the circular disc. Moment of inertia of this about an axis passing through the center perpendicular to the plane. Let us take that as I. This is equal to m r square by 2. Moment of inertia of a disc about an axis passing through the center perpendicular to the plane is m r square by 2. Now, from this a portion is removed from the edge as shown. So, diameter of this is r, radius of the removed portion will be r by 2. Okay. So, here moment of inertia of the removed part, let us take it as IR, moment of inertia of the removed part about this axis. This axis becomes tangential axis perpendicular to the plane. For a disc of mass m, radius r, moment of inertia of this is mr square by 2, tangential axis perpendicular to the plane. After taking parallel axis theorem, it becomes 3 by 2 mr square. So, here 3 by 2, mass of the removed part is 1/4 the initial mass, because this is a disc, mass proportional to r square. As a radius is half here, mass becomes m by 4, 3 by 2 m r square. R square is r by 2 whole square. So, moment of inertia of the removed part is 3 m r square by 4, 2 and 4. 2 4s are 8, 4s are 32. So, this is 3 m r square by 32. That is moment of inertia of the removed part about the original axis. Now, moment of inertia of the remaining part about the original axis is moment of inertia of the total disc about the natural axis minus moment of inertia of the removed part about the same axis. That is m r square by 2 minus, how much is this? 3 m r square by 32. 3 m r square by 32. If you take 32 as LCM, mr square as a common factor here, 16 minus 3. This is, see, 16 minus 3, it is 13. So, moment of inertia of the remaining part about the original axis is 13 by 32 mr square, 13 by 32 mr square. That is the first option given over there. Is it all right? Move on to the next.